Hello everyone. In this presentation, we are going to understand how to work with touchscreen display. So the screen that what you are seeing here is a welcome screen. You can able to see the car. This is the touch screen from the DWIN, which is a 480 cross 272 ratio. So this is the touch screen where you can able to touch and you can able to see the scrolling up down as you can see. So this touch screen is interfaced with the node MCU. This node MCU is interfaced with two LEDs which are considered as two devices. Both the touch screen and the node MCU is powered by a power bank as you see here. So here this touch screen is used to switch on the device and switch off the device with the touch. So if you look at the screen, I am scrolling up this touch screen. As you see here, I am scrolling up this touch screen from the welcome screen. Here I am able to get two switches. So there is one switch which is showing it as off with the red symbol. There is another switch which is a slider switch which is showing it as off condition. So when I press this button, you can able to see the green LED is glowing. When I press this button, you can able to see the red LED is going. So red LED off button, green LED off button, green LED on button and red LED on button. By touching the corresponding position in the touch screen, we are able to switch on the green LED, we are able to switch on the red LED. By touching the another position, we are able to switch off the red LED and switch off the green LED. So from this experiment, it is very clear that I can able to switch on and switch off a particular appliances with the help of touch screen. How this is happening, that is what we are going to see now. So if you see, this touch screen is connected with this node MCU through the UART serial communication where TXD and RXD. So there is a TXD and RXD which is coming here, and this GPIO is connected to two LEDs. That's all. So when I touch this particular button, say for example, when I touch this particular button, a serial data is transmitted to this node MCU. The node MCU receives the corresponding data, and if it is 55 means LED 1 will switch on. If I press this button, 56 will get transmitted. If you are transmitting 56, red LED will switch off. So 55 and 56 is the value which is helpful for us to switch on and switch off the corresponding LEDs. So that is what we are going to see. So if I press this first switch, 55 will get transmitted. If I press the second switch, 56 will get transmitted. If I press this switch, the corresponding data will not get transmitted. So that is why it is switched off. So thus by touching, so the DWIN display is designed in such a way that for every touch, the corresponding byte will get transmitted. By receiving that byte, you can able to switch on and switch off the particular application. That is what we have seen now. So we can see a little bit in depth how best it works by looking at the block diagram. If you look at this block diagram, you can see touchscreen based device control. Here you can see the touchscreen module from DWIN width of 480 cross 270 pixels. So it interconnected with the node MCU through UART. So where TXD and RXD is connected like this. In this node MCU, you have connected one device and another device. This may be two LEDs here in our example. So this is the hardware setup as we have seen now. And the software for the touchscreen setup, we are using the DWIN DGUS tool. The tool which is used for this touchscreen arrangements is by DWIN DGUS tool. And after receiving the data from the touchscreen module, the on-off is done by using the Arduino IDE. So DGUS tool is helping us to develop the touchscreen setup to send out the data serially. Arduino IDE is helpful for us to write a code for node MCU which receives the serial data, and then based on the data we are switching on the appliance and switching off the appliance. Let us see the software development steps laptop. This is the DWIN DGUS development tool. Here you can able to see the welcome screen. You can able to see the car, which is the welcome screen. This car is coming in the front screen. This car is coming as a front screen, and this is done by using this icon display. So there is an icon display here. By using this icon display, by using the variable icon display, we are able to bring this car in the front screen, and we have done some touch control. Here you can see the touch control. In this touch control we are using the page sliding control. We are using the page sliding control. So the page sliding control is nothing but the second screen, as you see here. So this is the second screen where, so the on off button, there are two buttons here. So the two button touch environment is shown here, and this rectangle box is to go back to the previous window. So these two touches, as you see here, will help us to send out the data serially 55 and 56. If we touch this particular portion, you are able to see there is a matrix. You are able to see the which row, which column it is being shown here. In this zone, wherever you touch, 55 will get transmitted to switch on, and in this zone, wherever you touch, 56 will get transmitted. So that is what the principle behind this touch screen. And when you go to this Arduino, so this is what the code that we have developed for the Arduino board to control the appliances. So totally there are 8 bytes will get received from the DWIN display. Those 8 bytes, the 8th byte is our information data. So quickly, if you look at the code, we are using two LEDs where D3 and D4 pins of the node MCU is being used. If 3 and 4, if you are replacing with D3 and D4 with 3 and 4 means it can be used for, the same code can be used for Arduino Uno and all type of Arduino development boards. So LED 1 is D3 and LED 2 is D4 GPIO. After that, we are receiving the serial data with the baud rate of 115200, and the LED 1, LED 2 is configured as an output mode, as you see here with the help of pin mode, and we are reading the serial data. If the serial data is available, as we told, there are 8 data byte will come. So in the for loop we are receiving the 8 bytes. 8 bytes which we are receiving is 5A, A5, 06, 83, 55, 00, 01, 00 and 01. So this is the value that we will be receiving. So all the 8 bytes. So for I equal to 0, I less than or equal to I plus plus. So the buffer of I means there is a buffer size of 8 is available. So all the buffer of 0 will be keeping the first received byte. Buffer of 1 will be having the A5. Buffer of 2 will be 6. Buffer of 3 will be 83. Buffer of 4 will be 55. So all those things. So if buffer of 0 is 55A, if the buffer of 0 is 5A, yes, buffer of 0 is nothing but the first value, which is 5A means this is the stable syntax. 5A will get received normally. When you receive 5A, you are looking at the 4th location of the buffer. So this is 0, 1, 2, 3, 4. The 4th location if it is 55. The 4th location if it is 55, then if the 8th byte, if it is 1 means 55 means the first switch, and this is 1 means first switch is on. So if it is 1 means you are writing a digital write LED 1 as high, so the LED will glow. Else if you are not receiving that 0, 1 means you are writing the low value to the LED 1, so LED will switch off. Instead of that, for the second device, you are checking for 56. If you are receiving 56 and if the 8th byte is 1, you are switching on the LED. If not, you are switching off the LED. Similarly, like this, n number of devices can be connected to available GPIO lines, and then you can switch on and switch off from the touch screen as we discussed. Thank you.